Hello student, today we're gonna learn rules to obtain integrating factor of differential equation mdx plus ndy is equals to 0. In the last two lectures, we have learned that rule number 1 and rule number 2 to obtain the integrating factor for the differential equation mdx plus ndy is equals to 0. Now today we're gonna learn rule number 3. What is the rule number 3 is? If the equation mdx plus ndy is equals to 0 can be written in the form of f1xy y dx plus f2xy x dy is equals to 0 and mx minus ny is not equals to 0, then 1 upon mx minus ny is an integrating factor for the this differential equation mdx plus ndy is equals to 0. Okay, so let us see that rule number 3 is, okay, first of all we can write mdx plus ndy is equals to 0 into the format a function of xy into y dx plus function of xy into x dy is equals to 0 and and m into x minus n into y is not equals to 0. So let what is m here? This total is our m function, and what is n function here? This f2xy into x is n function. Suppose m into x minus n into y is non-zero, then 1 upon mx minus ny is an integrating factor for this differential equation. Okay, so basically rule number 3 says that if the spatial format given in the differential equation, then we can write directly integrating factor as 1 upon mx minus ny, provided that m into x minus n into y never be 0, right? mx minus ny is not equals to 0. Okay, please don't confuse here. This is m into x, not the m ka partial derivative with respect to x and n ka partial derivative with respect to y. Here m into x minus n into y. Now let us see examples on the rule number 3 is, okay, now solve uh, solve y into 1 plus xy dx plus x into 1 minus xy dy is equals to 0. Okay, so first of all compare with m dx plus n dy is equals to 0, right? Okay, so let us see here. What is m? M is y 1 plus xy and n is equals to x 1 minus xy, right? Let us see first of all this differential equation is exact or not. Okay, now we need dou m by dou y. Okay, so dou y of, we can write this as y plus x into y square, which is dou by dou y of y is 1 plus 2xy. So dou m by dou y is 1 plus 2x, 1 plus 2x into y. Now dou n by dou x we need, so it is dou by dou x of x minus x square y. So this is equals to 1 minus 2xy, right? Okay, now dou n by dou x. So this implies dou m by dou y not equals to dou n by dou x. So this implies we call it as equation number 1. Okay, equation 1 is not exact differential equation, right? Now, this is not the exact differential equation. So it is not necessary that we can't convert it into the exact one. Okay. Now we can convert it into the exact differential equation by multiplying by suitable factor, and that suitable factor is called the integrating factors. Now equation one can be written in the form, look at here, student. 1 plus xy is a function of xy. So f1 xy into this y dx plus 1 minus xy. It is a function of xy. f2 xy into x dy is equals to 0. So look at the rule number 3. We can write m dx plus n dy. We can write m dx plus n dy is equals to 0 into function of xy into y dx plus function of xy into x dy is equals to 0. Then integrating factor in that case is 1 upon mx minus n. Right? Let us check here. Now, to check m into x minus n into y is not equals to 0, then integrating factor is equals to 1 upon m into x minus n into y by rule number 3. Correct? Okay. Now, m into x minus n into y. What is m here? What is m? M is y into 1 plus xy, y into 1 plus xy into x minus what is n here? X into 1 minus xy, x into 1 minus xy into y, which is equals to, we can write it as xy 1 plus xy minus xy 1 minus xy. We can take xy as a common. So 1 plus xy minus 1 minus minus plus. So it is xy. So minus 1 plus 1 get cancelled. So xy into this xy plus xy, it is 2xy and 2x square y square, which is not equals to 0. Then integrating factor is equals to 1 upon mx minus ny, which is equals to 1 upon 1 upon 2x square into y square. So integrating factor is equals to 1 upon 2x square y square. Right? Okay. Multiplying integrating factor to equation number 1. Right? So 1 upon 2x square y square. Now the equation number 1 is, what is equation number 1? Y 1 plus xy dx. So we can write it as y plus xy square, y plus x y square, x y square dx plus x minus x square y, x minus x square y dy is equals to 1 upon 2x square y square into 0. So 1 upon 2 y plus x y square upon x square y square dx plus 1 upon 2 x minus x square y upon x square y square dy is equals to 0. So we can write it as so 1 by 2 y and this y square get cancelled. So we are remaining with 1 by 2 x square into y plus this y square and y square get cancelled. X with cancel with x square. So we are remaining with 1 by 2x dx plus 1 by 2 x cancel with the x. So it is x y square minus x square get cancelled, y cancel with the y square, then we are remaining with 1 by 2 y dy is equals to 0. We call it as equation number 2 and this is our m dash and this is our n dash, right? So equation number 2 is exact differential equation. So here equation 2 is exact differential equation with m dash is equals to, what is m dash? 1 upon 2 x square y, 1 upon 2 x square y minus, sorry, plus 1 upon 2x and n dash is 1 upon 2 x y square, 1 upon 2 x y square minus 1 upon 2y minus 1 upon 2y. Now, so, and we know that, and we know that solution for exact differential equation. What is that? Integration m dash dx, where y treating as a constant, y constant, plus integration terms free from x in n dash dy is equals to some constant c, right? So integration treating as a y constant, what is n dash? 1 upon 2 x square y plus 1 upon 2 x dx plus terms free from x in n. So we can't take the first term because it contains a x. So terms free from x in n dash is only minus 1 upon 2y. So it is minus 1 upon 2y dy is equals to c, right? So we can integrate this with respect to x by treating y as a constant. So if we take the 1 upon 2y constant and we can write this x square as x raised to minus 2 dx plus 1 by 2 1 upon x dx y constant minus 1 upon 2 integration of 1 upon y dy is equals to c. So 1 upon 2y x raised to minus 2 integration is x raised to minus 2 plus 1 upon minus 2 plus 1 plus 1 by 2. This is 1 upon x. It is 1 upon x. 1 upon x ka integration with respect to x is log x minus 1 by 2. 1 upon y ka integration with respect to y is log y is equals to some constant c, right? So we can write it as x raised to minus 2 plus 1 is x raised to minus 1, and minus 2 plus 1 is minus 1. So we can write it as 1 upon 2 xy plus half log x minus log y is equals to some constant c. Right? Okay. So we can take the minus half common. So it is 1 upon xy minus log of x minus log y is equals to some constant c. Right? We have taken minus 1 by 2 as a common from this side. So minus 1 by 2, 1 upon xy, we can write it as log of x by y is equals to c. Okay. So we can write this minus 1 by 2 to that side. So it is 1 upon xy minus log xy is equals to minus 2c, and we can write it as minus 2c as a new constant c dash. So 1 upon xy minus log x by y is equals to c dash is the solution to exact differential equation 2. And we can conclude that this is solution for equation number 1 also. Right? So we have found that the solution for the 1 is 1 upon xy minus log of xy is equals to c dash. Right? So this is how we can use the rule number 3 and find the integrating factor to get the solution for the non-exact differential equation. Okay. Now let us see the second example on that. So what is the second example? Solve y xy plus 2 x square y square dx plus x xy plus x square y dy is equals to 0. Huh. First of all, can we write now here? We can write it as y xy plus 2 xy square dx plus x xy plus xy square dy is equals to 0. So this is in the form f1 xy into y dx plus f2 xy into x dy is equals to 0. That means we can write mdx plus ndy in the format of function of xy into y dx plus function of xy into x dy is equals to 0. Then the integrating factor for this, then integrating factor is equals to 1 upon mx minus ny when mx minus ny is not equals to 0. Right? Okay. Now, we mark it as a equation number 1. So compare with m dx plus n dy is equals to 0. So m is equals to y xy plus 2x square y square and n n x xy plus x square y square. Right? So first step, always check the exact or non-exact one. Then we can find the integrating factor. Right? Okay. Now we can write it as, so this is x y square plus 2x square y cube and n is x square y plus x cube y square. So this implies dou m by dou y is 2xy plus 6x square y square and dou n by dou x is equals to 2xy plus 3x square y square. Now clearly dou m by dou y is not equals to dou n by dou x. So this implies equation 1 is not exact differential equation. Now we can think of the integrating factor, right? Now given equation, we can write it in the form of f1 xy into y dx plus f2 xy into x dy is equals to 0. In that case, rule number 3 says that integrating factor is 1 upon m into x minus n into y, provided that m into x minus n into y non-zero, right? So therefore integrating factor is equals to 1 upon mx minus n y. So 1 upon what is mx? What is m here? M is this and n is this. So x into xy square plus 2x square y cube 2x square y cube minus y into what is n? X square y minus, sorry, it is plus x cube y square right? Okay, so we can write it as 1 upon x square y square plus 2 x cube y cube minus x square y square minus x cube y cube, right? Okay, now we can cancel it out, this x square y square and we can cancel it out this x cube y cube from this. So we are remaining with 1 upon x cube into y cube, right? And this mx minus ny neighbors 0, where x cube into y cube not equals to 0. So therefore integrating factor is equals to 1 upon x cube y cube. Now multiplying integrating factor to equation 1. Now 1 upon x cube y cube. Now what is equation number 1? Y xy plus 2x square y. We can write it as xy square plus 2 x square y cube dx plus x square y minus x cube y square dy is equals to 1 upon x cube y cube into 0. Correct. So this is our m dx plus n dy. Just we have to multiply 1 upon x cube y cube on the both side. Right. So this is equals to, if you multiply this inside, then y square and y square get cancelled. We are remaining with y and x upon x cube is 1 upon x square. So it is 1 upon x square y plus 2. Now y cube and y cube get cancelled. X square get cancelled with the x cube and we are remaining with only x. So 2 upon x dx now plus x square cancel with x cube. So we are remaining with 1 upon x and y cancel with the y cube. So we are remaining with y square minus x cube and x cube get cancelled. We are remaining with 1 upon y dy is equals to 0. We call it as equation number 2. So here this is our m dash and this is our n dash. This is our m dash and this is our n dash. So this implies equation 2 is exact differential equation with m dash is, what is m dash? 1 upon x square y plus 2 by x and n dash is 1 upon xy square minus 1 upon y. Okay, there is no need to check that equation number 2 exact or not because we have already multiplied the integrating factor so that this equation becomes an exact differential equation, right? And we know that solution to exact differential equation is, what is that? Integration m dash dx, y treated as a constant, y constant, plus integration terms free from x in n dy is equals to c. Now remember, this is our m dash and this is our n dash, right? Okay, so y constant, what is m dash here? What is m dash? We have written that 1 upon x square y, 1 upon x square y plus 2 upon x dx plus 2 upon x dx plus terms free from x in n dash. Only the terms free from x is minus 1 upon y. So we have to write that minus 1 upon y dy is equals to some constant c. Now, remember here we have to integrate with respect to x treating as a y constant. So this is 1 upon y. Now, 1 upon x square का integration is x raised to minus 1 upon minus 1 plus 2 constant 1 upon x का integration is log x minus 1 upon y का integration is log y is equals to c. Now here we have used that integration x raised to n dx as x raised to n plus 1 upon n plus 1 plus c. One can say that why we not add up here c here, because we have already add up in the right hand side. So we here there is no need to add the c, right? Okay. So this is minus 1 upon xy plus 2 into log x, we can write it as log x square, log of x square. Now, this is plus, sorry, we have mistaken here. This is plus, this is plus, this is plus, because what is m here? Sorry, what is n? It is x into xy plus x square y square. So just correct it. This is plus. Okay. Now this is also plus. So then it is plus. So plus log y is equals to c. So we can write it as minus 1 upon xy plus log of x square y equals to c by log property. Log property. So we can write it as log x square y is equals to c plus 1 upon xy is solution to exact differential equation 2. Then we can write this is solution for equation 1 also. I hope you understood this second sum. We have found the integrating factor by rule number 3, and after that we have found that the solution for the non-exact differential equation. I hope you understood. Thank you.